So, comparison 4. So now with all of the information that we've developed so far, we now are going to look at the economic viability of a power plant for the 3 different load profiles utilizing the reliable solution that we put together, which was the 7 turbines, I believe it's 18 medium speed engines, and the 115 M2 2.5 megawatt Rolls-Royce units. And what we were able to show is by first of all, being able to deploy equipment quicker, we were able to achieve first power quicker. We were also able to, in comparison to turbines, reduce our fuel consumption overall. Now, one thing you will note is turbines will have the highest fuel consumption, and that's just purely because they're going to be ran in a lower overall turn down rate, which increases their fuel consumption. However, they do also have the lowest maintenance cost, and I do want to highlight that. But also they have the highest capital deployment due to that overbuild that we had talked about. Now, in this model I'm showing here, I intentionally did not include any financing costs. However, if you were to want to look at your unique financial cost of debt or cost of capital, we can definitely model that in a unique report for you. But what you'll notice is that engines both were able to achieve dramatically lower overall levelized cost of power or total cost of power. And the smaller recips are able to have a lower overall financing cost, lower CapEx cost, and achieve an overall higher IRR. So what we were able to show over a 25-year period is that the high-speed solution for this 250 megawatt power plant was able to achieve an IRR of 17%, a simple payback over 8 years, and with an NPV at a 5% discount of $666 million over that term. Medium speeds 14, and simple cycle turbines at 9%. And the primary reason for a lot of the benefit was the speed of deployment and the benefit of first power. Now, that was for a hosting load data center. Now let's look at it for an AI training. And what I wanted to highlight and what I want to point out here is that the AI training has a similar overall similar power consumption to the hosting. And we'll get into that in a little bit here on the AI inference comparison. But what you're seeing here is a similar scenario where the fuel on the turbines was the highest, the O&M was the lowest. But again, what we're seeing here is quickest power to market and revenue generation on the high-speed solution. So overall slightly lower overall IRR in comparison. And one of the things I have not included in the calculations is the cost of the battery and any sort of power conditioning that was required, which would ultimately reduce this a little bit further. Now, this is where I want to speak to AI inference data centers. And this is where the economics really get impacted by that overall lower utilization. Some people will call that stranded power. And so what you're seeing here is much less fuel consumption in comparison to the other two. And while that looks good, the reality is the reason why it's lower is because we're just not generating as much power. And because we're not generating as much power, but we've still deployed the same amount of capital, we really see an impact to our overall economics. So much lower rates of return, negative NPV at 5%, and very high simple payback.